Okay, guys, this is Mr. Ainsworth. We're in part 3 here in chapter 8 review number 3 here, and we're going to focus on solving equations with multiple solutions. Okay, so let's get started here. We're going to solve cosine x times cotangent x equals 2 cosine x from 0 to 360, which means we're going to need our answers in degrees here. Alright, so let's get started here. We've got cosine x times cotangent x equals 2 cosine x. I notice that I have a common factor here. So when I have a common factor, typically what we do is we get it to one side and factor it out. Okay, so let's do that. Let's set it equal to 0 here. And we have cosine x times cotangent x, okay, minus 2 cosine x, because I just subtract it and get it on the other side. Alright, I see a common factor here, and whenever I see that, I factor out the GCF. Alright, so I get cosine x times the quantity, cotangent x minus 2, equals 0. This is a common skill that we use in Algebra 1 and 2. It happens when you have something like this, 2x squared minus x equals 0. We factor out the x like this, and we set each factor equal to 0 and solve. Okay, that's what we did in Algebra 1 and 2. Alright, but here we have cotangent x and cosine x, so just kind of go the same flow, use the same skills. Okay, now we set each one equal to 0 and solve. Alright. And then the next one, cotangent x minus 2 equals 0. Now here we have cosine x equals 0, and that's equal to 0 at 90 and 270 at the bottom and the top of the unit circle. Okay, so we have 90 degrees here and also 270. Here I need to isolate the function, add 2. Let's get on the right hand side. Can't take the inverse cotangent on the calculator, so I'm going to reciprocate both sides. And this is the same as tangent x equals 1/2. And that's positive in quadrant 1 and 3. So I've got a quadrant 1 solution, quadrant 3 solution. So what I need to do is take the inverse tangent of 1/2 and get an angle. Okay, now since that 1/2 is not on the tangent ratio of 1/2 is not on our special right triangles, that implies that we need a calculator. So we take the inverse tangent of 1 divided by 2. I'm going to hit mode here. I'm going to see that I'm in radian mode, so I'm going to switch it to degrees because I want my answers in degrees. I could have done it after I figured out the inverse tangent, but I'm going to do it before. I'm going to quit out, and I'm going to hit enter, and I get 26.565. Alright, so my first angle, my first solution is 26.565 degrees. To get to quadrant 3, you just add 180. That's all you do. So here, you just go plus 180. Hit enter, and you get 206.565. So my second solution is found by taking 180 plus 26.565. So my second solution is 206.565 degrees. So I have 4 solutions: 90, 270, 26.565, and 206.565. Okay, all in degrees. That's my first one. Alright, let's take a look at number 2. Here I have an equation with 2 functions involved, and I notice that cosine is being squared, which is always an identity. Okay, a Pythagorean identity. So what I'm going to do is going to substitute it in, because I love saying that, I know that cosine squared theta equals 1 minus sine squared theta. So all this goes right in through here. So let me just rewrite the equation over here so I can get started. Okay, I'm going to subtract 3 first. The reason why we do that is because it's quadratic and you always get them equal to 0. I'm going to substitute what I know of cosine theta here. I know that it's equal to 1 minus sine squared theta, so I substitute that in. 1 minus sine squared theta plus 3 sine theta minus 3 equals 0. So what you saw in yellow here, those two things are equal. Just substitute it in. Distribute through a couple times. You get 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. And it's a quadratic here, and the leading coefficient is negative, so I'm going to get everything on the right hand side. So get everything over here. So I'm going to add 2 sine squared theta, get it on the right. See, 2 minus 3 is negative 1, but when I add a 1, I get positive on the right. And I'm going to subtract the 3 sine theta. Okay, and that 2 minus 3 is a negative 1, but when I add it, I get a positive 1, and that's equal to 0. It's always easier when the leading coefficient is positive, especially when you try to factor this. Okay, so we're going to try to factor now. So we're going to try to 2 sine theta times sine theta. That's going to be equal to 2 sine squared theta. The factors of 1 go in. I'm going to try to get a negative 3 by making both negative. So I try to factor here from here to here. That's the factoring step. And then I set both equal to 0, like I always do in all my examples. Whenever you factor, get in factoring, you always set both factors equal to 0, and you solve each. Here you get sine theta is equal to 1/2, and that's when sine theta is equal to, theta is equal to 30 degrees. Here's a 30, 60, 90 here. 2, 1, rad 3. Sine of 30 is 1/2. So you get 30 degrees here, and also 150 in quadrant 2. That's 30 degrees. And here we get sine theta equals 1, and that only happens at 90 degrees. Okay, all solutions less than 360. So I get 3 answers here. All right, and that's problem number 2. I apologize for my dogs in the background. They're playing. They're having fun. Okay, number 3, we have 4 sine pi force x equals 1, and when I isolate the function here by dividing by 4, I get sine of pi force x equals 1/4, which indicates that this requires a calculator here, because 1/4 is not on my special right triangles. So here, calc required. So this is a good calculator example. Alright, because of this right here, because of that ratio. I'm going to take the inverse sine, and I get pi force x is equal to the inverse sine of 1/4. Which gives me 2 angles in quadrants 1 and 2. So I've got pi force x here is equal to whatever this is. So we take the inverse sine, and see I need to be in radians here, so I'm going to switch back to radians. Okay, so switch back to radians, clear the calculator out, take the inverse sine of 1/4. Okay, there's my answer in quadrant 1, and then I go pi minus 180 in quadrant 2 to get to quadrant 2. So, pi minus my angle. So I take pi, okay, minus my answer. There's, oh shoot, what happened there? Let's go ahead and clear that. Okay, I want pi minus, I meant my answer there. There we go. So this is quadrant 1 and there's quadrant 2. So let me write those down. So I've got 0.252. That's my quadrant 1. My quadrant 2 was a 2.889. So 2.889. That's my quadrant 2. This is quadrant 1. Quadrant 2, I got pi minus the 0.252. That's how I did it. Okay. Plus multiples of the period. So plus 2 and pi. Okay. This is called multiples, okay, of the period. Now the period of sine is 2n pi. Multiples of period. All right. However, the original, the period of this one up here is 2 pi divided by pi force. Now, because b is 8 here, b is pi force, which means period of this function up here is 2 pi divided by pi force, which happens to be 8. So watch what happens here. When I multiply everything through by the reciprocal here, which is pi 4 divided by pi, I get my first set of solutions. I get x is equal to this times 4 divided by pi, comma, this times 4 divided by pi, and then this times 4 divided by pi, which happens to be 8 and 8, or 8n, which happens to be the period. Okay, so I need to get 2.252 times 4 divided by pi. That's my first solution. Then I got to take this one, multiply by the same thing. So 2.889 times 4 over pi, plus my period, 2n pi, times 4 divided by pi, which happens to be, guys, check it out, you get 8n. That's my period of the original function. All right, that's how I get a lot of solutions. And I need to figure this out. So here we go. Okay, so let's pull up the calculator in here and let's start working on this here. My first solution here is already up. All I have to do is times by 4 and divide by pi. So times 4 divided by pi. Hit enter. So I'm going to start working here first since this was already up on my calculator here. So I got 3.678. Okay, and that happens to be, let me see, 4, 2, 2. Hang on for a second here. Okay, I'm back now. I was just checking something here. I get my first solution here at 3.678. So I'm going to write that down here. So 3.678. 3.678. That's less than 2 pi or 6.28, so that's the solution there. And I want to add, if I add 8 to that, okay, notice if I add 8 to that, I'm way beyond 2 pi, which is 6.28. So there's no need to add multiples of my period here. This is the multiples of the period of the function up here. Multiples of the period. If I do that, I will get solutions, but they'll be beyond 2 pi. Okay, I have to have solutions less than 2 pi. So I've got a solution here, and I've got to figure out my next solution. So what I need to do is recall this 0.252, which is right up here. So I got 0.252 and then 68. That's enough digits there. That's to be accurate enough. All right, times 4 divided by pi. So times 4 divided by, whoops, got to go back here. Nope. Oh, let me clear it out. Let me start over again. 0.252 and then 680, so 68, and then I want to multiply by 4 times 4 and then divided by pi. There we go. All right, and I get that solution. So 0.322 roughly. 0.322 radians. So I've got two answers here, two solutions that are less than 2 pi. If I add 8 to either one of them to get more solutions, I could do that. Plus 8, plus 8. That's my period now. That's how you get a lot of solutions. I get 8.322. Here I get 11.678. These are solutions as well, but they're beyond 2 pi, so we're not going to count these. These are greater than, 2 pi, greater than 2 pi. So we only have two solutions here. We have these two right here. We can verify that too. We could, if we want, let y1 equal to sine of pi force x, okay, and let y2 equal to a fourth, y2 equal to 1/4, and intersect these. So graph, okay, and intersect, okay, to check. In fact, let's do that real quick just so that you can see it. So let's go up here. Let's go to the y equals. Sin x is already in. I need to go down here and clear it out and put in 1/4. All right, I'm going to go zoom 6. Okay, too hard to see, so we're going to have to set the window here. Let's set the window from 0 to 2 pi. This will make it a little bit more clear. And then let's set our y minimum to 0 because the solutions are above the x-axis here. Let's set this to 1. And we're going to be able to see a whole lot better. See, so it intersects here and here. So let's check this intersection point. Let's go second trace, which is calculation. Hit number 5. Go enter, enter for first and second curve, and put my cursor right back on my guess. Okay. And ooh, let me see. You know what I didn't do? I apologize. I didn't enter the correct function. I put sine of x. I want to put sine of pi force times x. Aha. So you have to start with the right function here. So let's put in pi. All right. Pi x divided by 4. There we go. Pi x divided by 4. That's pi force x. It's the same thing. And I'm going to regraph and then redo this. So second trace, number 5, enter, enter. I put my cursor over here. There we go. There we go. 3.678. Okay. And that corresponds to this solution here. And I know if my second solution is correct, I know my first one is. So, but if you want to check it, you just go second trace, go number 5, enter, enter. Put your cursor back on the left-hand side here. Do this just in, because this video, I want to show you that, how to check your answers. And there you go, 0.322, which is this one here. So let me grab this here. Boom. There we go. Takes a second. Give me a second here. All right. Let me move this around here a little bit. Actually, that's good enough. So, all right. So what we have here is the graph. Here we have sine of pi force x here, and we have a horizontal line. This is y equals 1/4 here. This is my y2. My y1 here is sine of pi force x. All right, and here's my intersection point. That's what this is right here. Okay? So awesome. You can check all your answers using your graphing calculator if you like. All right, number 4. This is going to be a fun one. So we have 5 times the sine of 3x equals -2. I'm going to isolate my function here. I get -2/5. Now sine's negative in quadrants 3 and 4, so I got to remember how to get those solutions there. I'm going to take the inverse sine, so I get 3x is equal to the inverse sine of -2/5. Okay, plus multiples of the period, of course. So I get 3x is equal to something in quadrant 3, and then something in quadrant 4, plus multiples of the period, plus 2 and pi. So, what do we get? I need to take the inverse sine. So let me grab my calculator again. So quit out here. All right, so I take the inverse sine of -2/5, and I get about -0.4115, which is my quadrant 4 angle. All right, and I need quadrant 3. Now my reference angle is positive 0.4115, so let me just note that down. My reference angle is 0.4115 radians. To get to quadrant 3, I got to add pi to that. All right, so what I need to do to get to quadrant 3 is I just make that negative. So let me take my answer, multiply it by -1, so times -1. That'll make it positive. Add pi to get to quadrant 3. Now you can tell that's quadrant 3 because pi is 3.14. This is bigger than that, so you know you're beyond pi radians, so you're in quadrant 3. And then, so it's 3.553, so 3.553 plus my quadrant 4 angle. Okay, now I take my quadrant 4, I take 2 pi minus this reference angle to get to quadrant 4. So let me do that. Okay, so I've got 2 pi, all right, minus this angle here, 0.4115, and that will put me in quadrant 4, see? So I get 5.87, let's say 2. So 5.872 roughly, plus multiples of the period. But these really aren't solutions to my original function here, sine of 3x. I have to divide everything by 3. So I got to divide this by 3, this by 3, this by 3, and this by 3. And this is my period right here. And this makes sense because b is 3 here. All right, and p is equal to 2 pi divided by b in general, or 2 pi thirds. This is my period, which corresponds to this. This is the period. And this is how you get multiple solutions, as I keep on saying. But first I got to divide everything by 3. So what do I get? Okay, so like I said, it's a calculator problem. So you get your answer here. I might as well just take this one first and divide it by 3 because it's already on the calculator. And I get 1.957, excuse me. So 1.957 plus 2 pi thirds, multiples of the period. I got to take this one here and also divide it by 3. So 3.553 divided by 3, that would be about 1.184. So got to write it down correctly here, 1.184. Let me verify that. And that looks good. So I got my first solutions here. And then from there, all I do is add multiples of the period to get more solutions. Okay? Add 2/3 pi, multiples of the period, multiples of the period, all right, to get more solutions. Okay, and then you just stop when you're bigger than 2 pi. So x is less than, 0 is less than or equal to x less than 2 pi radians. We're in radian mode here. Okay, so what I need to do is add 2/3 pi, and then add 2/3 pi. You just keep on doing this. And then over here you add 2/3 pi, and then you add 2/3 pi. That's a 2/3 pi there. You write it more clearly. And this is how you get more solutions, guys, every single time. You start off with the first two after solving for x, and then you add the period multiple times. And then you stop once you're bigger than 2 pi. So grab the calculator again. We're here. We're going to add 2 pi divided by 3. So plus 2 pi, all right, divided by 3. There's my next one. And then plus 2 times pi, all right, divided by 3. And if I wanted to, just hit the enter button again, and you get more and more solutions. Keep pressing the enter button, and it'll do that operation for you. Once you do it twice, then you don't have to do it any more times. You just keep on hitting the enter button. Okay, so let's record these. And then my next one here is 3.279. All right, 3.279. 3.279. My next one is 5.373. 5.373. And now I got to work on this, and I have to add multiples of the period. So let's get this one back. So 1.957, and then I have to add 2 pi thirds. There we go, right there. That's my next one. Add 2 pi thirds again. And if you want to do it again, you just keep hitting the enter button. Okay? Okay, so what I did was, my next one is 4.051 basically. So 4.051. After that, add in another one there. I get 6.146. 6.146 radians. And I've got to stop there because if I add another 2/3 pi, I'm beyond 2 pi. Okay? So I've got 6 solutions. And that makes sense because what's happening here is this, is that you have this sine function here, and the period is not 2 pi, it's 2 pi thirds. So right here it's 2 pi thirds. Okay, and another period is right here, that's 4 pi thirds. All right, and another period is 6 pi thirds, which is 2 pi, okay? So what happens is it oscillates one time, and then oscillates again, and then oscillates again. Okay, and then this -2/5, is down here. It intersects 1, 2, 3, 4, 5, 6. 6 times, 6 solutions. 6 solutions. All right, so for each period, you get 2 solutions, but since it oscillates 3 times, okay, up and down, up and down, up and down from 0 to 2 pi, you get 3 times 2. Okay, remember, B is 3 here. 3 times 2 is 6 solutions. All right, 6 solutions total. All right, so when B is bigger than 1, all you do is multiply by 2 to figure out how many solutions you have. There you go. I'm talking about if it's a whole number. Okay, number 5, I've got 2 sine of 2x here equals 1. And I want to isolate the sine function again here. B is 2 here, so we're going to have 4 solutions. I can already tell that. So B is 2. Okay, we're looking for 4 solutions. All right, 2 times 2 equals 4, guys. So we need to take the inverse sine of a half. And again, here's your 30, 60, 90. Here, 2, 1, rad 3. And so sine of 30 degrees equals a half. So my first angle here in radians is pi 6. So I get pi 6 in quadrant 1, and pi minus pi 6 gives me 5 pi 6 in quadrant 2. So 5 pi 6 in quadrant 2 plus multiples of the period. Okay, once more, this is quadrant 1, this is quadrant 2, and this is multiples, I keep on saying this, of the period. And that's how you get more and more solutions, as many as you want. Now to get the actual answers here, you got to solve for x. So I got to multiply everything by a half, okay, or divide by 2, but it's easier to multiply a half. You get pi 12s here, and you get 5 pi 12s here, and then a half of 2n pi is just n pi, and there's my period. Period is 2 pi divided by 2, or just pi. Here's my period. Okay? And you just add that to the solutions to get more solutions. So I just add my pi, add a pi here to get another one, add a pi to get another one. Keep on doing that. Add pi here to get another one, add pi to get another one. Okay, of course you have to have common denominators, and as we know, pi is equivalent to be 12/12 pi, so I have to add 12/12 to each one of these to get another one. So I get 13 pi 12ths here. You just basically add 12 in the numerator. 1 plus 12 is 13. 13 plus 12 is 25, so I get 25 pi 12ths, which is 2 in the 12th, which is bigger than 2 pi. So we're not going to count this because it's greater than 2 pi. And then 5 pi 12ths plus 12/12 pi is 17 pi 12ths, and then plus 12 more is 29 pi 12ths. All right, but once again, this is bigger than 2 pi, so we only have 4 solutions. All right, and here they are right here. Okay, 4 solutions total. Okay, on my next one here, I've got cosine of 3x is equal to -1. Here, b equals 3. So my period, that tells me my period is equal to 2 pi thirds again. So I have multiple solutions here because it's contracted. All right, I want to take the inverse cosine. Okay, I have -1. And I get 3x is equal to whatever this is. Now, cosine, we know cosine of pi is -1. So this is pi plus multiples of its period, 2n pi. All right, so you just pi, and remember on the unit circle, here, right here, this is at -1 comma 0. Okay, so what this means is I got to keep on adding 2 pi, because we know that when you do that, you're at here at pi radians. When you add 2 pi, you go all the way around again. You're at 3 pi, and then I go all the way around again, 5 pi, and then so on. So my solutions here are basically pi, and then everything that's coterminal with that, which is 3 pi, 5 pi, 7 pi, okay, and the list goes on and on. That's what this does. You keep on adding 2 pi to get multiple solutions. Plus 2 pi, plus 2 pi, plus 2 pi. And you'll get to the same point because we know it's coterminal there. Okay, now I got to actually solve for x here because I haven't even done it yet. And I got to get my set of solutions here. So I get divide by 3 here, 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 everywhere. And I get my answers. I get pi thirds. All right. I get pi here. I get 5 pi thirds. All right. And then I get 7 pi thirds. But this right here is greater than 2 pi. So I have 3 solutions only. 3 solutions only. There we go. So pretty simple one, but it has multiple solutions. All right. My last one here, I have cosine of 8 times cosine of 2x equals 1. So 8 times cosine of 2x equals 1. I've got to divide by 8, so I get cosine of 2x equals 1/8, and this is not on the special right triangle. All right, so this tells me that calculator is required. Okay, so I need to take 2x and set equal to the inverse cosine of 1/8. All right, now I need to do that on the calculator, so let's clear this out, and we're going to do it in radians. So I'll have to make sure we're in radians. 1 divided by 8. There we go. Let me just check my mode. Okay, I'm in radian mode. That's good. So I get my first answer in quadrant 1, and then I need one in quadrant 4. So 1.445. So 1.445. That's my quadrant 1. All right. I need a quadrant 4 answer plus multiples of the period plus 2n pi. Okay. So to get my quadrant 4 answer, I got to take 2 pi minus my quadrant 1. So 2 pi minus 1.445, that will give me my quadrant 4. So I go 2 pi minus my answer, and I get my quadrant 4 result, which is 4.838. So 4.838, that's my quadrant 4. And then I divide everything by 2 and then start going for it. Okay? So I need to solve for x because I haven't done so yet. So just simply divide by 2. Okay, divide by 2, divide by 2, divide by 2, divide by 2. The reason why is because b is 2, and that tells me that the period is 2 pi divided by 2, or pi. It's contracted. So this oscillates twice from 0 to 2 pi, and we're going to have twice as many solutions. We're looking for 4 solutions here. All right, so let's get the first 2. All right, so I take this answer here. I'll just start with this one, divided by 2. So divided by 2, I get 2.419. So 2.419 plus n pi, that's my period there. That's the period. And then I got to take this one and divide it by 2. So I've got to take the 1.445. You can enter in 468 if you want. 468. Divide it by 2. The more digits you take, the better. The more accurate it is. 0.722. So 0.722. Those are my first 2 solutions. And then I have to add pi to them to get more. Plus pi. All right. Plus pi. Add pi here. Add pi here again. Again, you're going to add pi multiple times to get your solutions. All right. So let's do that. Let me see. I'm right here, so just add pi. So plus pi. And then plus pi again. Okay, I'm bigger than 6.28 here, so that means I'm bigger than 2 pi. So my next solution is 3.864. So and let's write that down. So 3.864. And then my next one, I'm going to write it down, even though I'm not going to consider it. 7.006. All right. This one is greater than 2 pi, so we're not going to consider that one because we want it less than 2 pi, which is 6.28 roughly. And then the next one here, I need the 2.419. Yeah, that's this one up here. So 2.418858. That's the one up top here. I have to divide it, or excuse me, I have to add pi to it. I took a lot of digits to be more accurate, and then add pi to it again. Okay, so my next solution here is 5.560. So 5.5, let me reread it again. 5.560. There we go. And then my last one here is 8.702. So 8.702. But again, I'm not going to consider this one because it's greater than 2 pi. Okay, we want it less than 2 pi. Less than. All right, 6.28. That's what this means. All right, so we have 4 solutions. There they are. And again, all you do is add the period to get more solutions. Add the period. All right, to find more solutions. All right, so just remember, this video, you go ahead and practice and multiple times as much as you want. Listen to me again as much as you want, and give it your best effort. Prepare for the exam, and I'll see you then.